So imagine you have a super smart robot that can learn from you and do things on its own. This is called, we are calling this as neural network, and it's made up of many tiny brain cells called layers that work together to help the robot make decisions. So think of each layer like a big box that, so let's say our robot here, and think of each layer like a big box that takes some information, does something with it, takes information, does something with it, and it sends out new information. And it takes in all the data a robot needs to learn from pictures or words or any data type. And the second box called is hidden layer. So because it is not visible, and it helps robot to figure out what's important about the information it got from the input layer. And it's like super smart filter that looks at lots of things and says, oh, I think this is really important. And after the hidden layer comes to the another box that is called output layer. This is hidden layer, this is output layer. This box takes all the good stuff from the previous boxes and sends out it to own prediction and about what it thinks to going to be. Like, I think this is a picture of cat or dog or whatever that can be, the prediction that it made. So let's talk about how these layers work together. When we put all these boxes together, we use special numbers called weights, which help us to understand each box process information. Now imagine you're building this thing with Legos, and each Lego brick has special number on it, like 5 or 3, and these numbers are like weights in our robot's brain. So we stack them up. They tell the robot which Legos to use next, and or which hidden layers to send information to. So when we want the robot to do something new, like recognize a cat, it uses all these boxes, weights together to figure out the whole thing. So here's how it works. So the input layer takes information from us, the hidden layer looks at that information and that says, hey, I think this is important, and sends the information to next layer. The second hidden layer does the own thing, and with the new information then it sends to the final layer, and it might be the output layer, and output layer looks at all the good stuff from the before and it make prediction about what's going on, like I think it is a cat. That's basically how forward propagation in our robot brain work. And yeah, that's like a basic intuition about the whole neural networks work. So basic neural networks we are going to draw. So this is normal logistic regression. So this is our logistic regression. Then this is our one hidden layer neural network. Then this is our two hidden layer neural network. So just don't mind my drawings, and we might have some layers more than 2 as well. So let's suppose we have this much layers of neural network, and we will call this as a deep neural network because we have a lot of layers and it might have different tasks to do, whatever each and every layer will be doing. So the notations for these neural networks will be like, let's suppose we have 4 layer neural network, then L will be equals to 4 and N of L will be equals to units of the layers in L, then let's suppose n of 1 equals to 5, n of 2 equals to 5, n of 3 equals to 3, n of 4 equals to n of 2 equals to 1, n of 0 equal to n of x equal to 3, and this thing is our activation in our layer L, that is z of L. Now we have this thing as a weight for computing ZL. Then our x is A0, then our x is input feature, that is A0. So that's the basic intuition for the complete thing. So that's all for this one. See you guys in the next one. Until then, keep grinding.